So let us see applications of Lamis theorem. So let us illustrate the example 1. Capital A and B are two smooth pegs in a horizontal line at a distance 5 meters apart. Two light inextensible strings CA and CB of lengths 3 meter and 4 meter respectively attached to these two pegs. Find the tensions in the strings when a weight of 10 kg is suspended from point C. So for this purpose we have I'll show you in the figure. This is a point A, that is a peg A and peg B, and we have joined these two by the horizontal line, which is a 5 meter long. Now this is a point C. Now these two strings, that one is a AC, that AC is this one having length 3 meter, and another is BC having length 4 meter, and then attach force or weight 10 kg at this point horizontally, vertically. Now how to write the solution? First draw the diagram and then give the details of the diagram. So now I am writing the details here. So let what we observe in the figure, that is length of, this is given. So I'll write here that is given length of AB is equal to 5, length of AC that is equal to 3, and length of BC is equal to 4 meters, right? Now tension T1 I am supposing along the CA, so I am mentioning here. So let T1 and T2 be tensions along CA and CB respectively. Okay. Now what this 10 kg weight is suspended at point C. So another force, this is a force, I am supposing this force is suppose T3 or F, and that is equal to what? 10 kg. So also F is equal to 10 kg at point C. Now AB and this dotted line are parallel to each other, and now AC is a transversal of these two parallel lines. Therefore, using the alternate angle, this angle capital A is equal to this angle, and therefore suppose I am giving the name as this as a D and this as a D dash. So therefore measurement of an angle ACD, that is equal to capital A, and measurement of an angle that is BCD dash, BCD dash is equal to capital B. Now the angle between here, this is a 90 degree. Therefore, if I am supposing this point is suppose E, then the angle between BCE is nothing but 90 plus B, and the angle between ACE is nothing but 90 plus this A. Therefore, measurement of an angle BCE is equal to 90, that means pi by 2 plus B, and measurement of an angle ACE is equal to 90 degree, that is pi by 2 plus capital A. Alright. Now what is the angle between this ACB? So the AB has length 5, another two has 3 and 4, therefore Pythagoras theorem is satisfied in this triangle. Therefore the 5 is hypotenuse, and therefore angle between ACB is nothing but a right angle. And therefore we can write here, since triangle ABC satisfy Pythagoras theorem, therefore measurement of an angle ACB is equal to 90 degree, that is what, pi by 2. Now in this figure we have seen three forces, that is, one is T1 because tension is nothing but a force, another is T2, and third one is F, that is given 10 kg, and we already known the angle between these three forces, and therefore when we know three forces or three angles, then we can use Lamis theorem. So since T1, force T2 and force F are in equilibrium, therefore by Lamis theorem, T1 upon sine of angle between remaining these two forces, that is T2 and F, equal to T2 divided by sine of angle between T1 and F is equal to F divided by sine of angle between T1 and T2. So what are the angles of T1 and T2? So if we go back, this is suppose T1 is here, so we have to consider this angle pi by 2 plus B, that is BCE, this angle. So for this is the measurement of an angle BCE. This is a measurement of an angle that is ACE, and this is a measurement of an angle ACB. Therefore T1 upon, this is a sine of pi by 2 plus A, it is not A, it is B, equal to T2 upon sine of pi by 2 plus A, and this is equal to F upon sine of 90 degree, that is pi by 2. So this is a compound angle whose first angle is odd multiple of pi by 2, and odd multiple of pi by 2 we can call as a lambda, and that lambda will change sine into cos. Therefore we can write this T1 divided by cos, and the next angle is B. The quadrant is second quadrant, and in the second quadrant sign is positive, therefore there is no issue of plus minus sign. So again here I am using the pi by 2. This is an odd multiple of pi by 2. It will change sign into cos, and the angle is A. The force F is given to us, that is 10 kg, and the value of sine 90 is 1. So therefore we are getting these three ratios. Now I am considering these three ratios. So considering first ratio and third ratio, I will get value of T1 is equal to 10 into cos of angle between the cos of B, and T2 is equal to 10 into cos of A. Alright. Now the only issue is how to get the value of this cos A and cos B. So for this purpose you go to the figure. In this figure, this triangle ABC is a what? Right angle triangle. And this is an angle A. Therefore we can use the trigonometry in this triangle. We know that cos of A is nothing but adjacent side, that is a 3 meter, divided by hypotenuse, that is a 5 meter. Therefore the value of cos A is 3 by 5, and value of cos of B is 4 by 5. So I am here writing from triangle ABC, the cos of A is equal to 3 upon 5, adjacent side upon hypotenuse, and cos of B is equal to, this is 4 upon 5. Now I am substituting these values in above equations of T1 and T2. Therefore I will get right here. Therefore this implies T1 is equal to 10 into cos B, that is 4 upon 5. It is nothing but 8 kg, and the T2 is equal to 10 into cos A, that is 3 upon 5, that is equal to 6 kg. And therefore this is the required answer. So T1 is tension is 8 kg, and another tension T2 is 6 kg.